Hello students, in this class we'll see Introduction to Arithmetic Progression chapter. What do you mean by arithmetic progression? What we are going to learn in this class we'll see one by one. You might have seen some numbers say 1, 2, 3 dash dash dash. What are these? These are set of natural numbers, right? If I say 2, 4, 6, these are set of even natural numbers, right? Similarly, if I say 2, 1, 4, 9, 16, these are set of squares of natural numbers. So these in this example we can see some sequence here, sequence based on the question. So it is nothing but arrangement of numbers. It sequence is nothing but orderly arrangement of numbers. Orderly arrangement of numbers as per some rule. If you know what, if you want to get what is the rule here, it is every number is 1 plus. Every number is equal to 1 plus previous number. That is the rule. Here if you see, every number difference is 2. Difference is 2. Right? What is the rule here? It is squares of the numbers. Means you may not find a difference, same kind of thing, but it's a square numbers. That is the rule. Every number is a square number started from 1. Okay, this is a sequence. Means it's orderly arrangement of numbers according to some rule. Then what are these in the sequence? The first term. First one is called first term. Second one is called second term. What are the terms? Terms are nothing but it is individual numbers in the sequence. What are the terms? Individual numbers in the sequence. Okay. Terms are nothing but individual numbers in the sequence. Okay. Moving on, how many terms are there in a sequence? We don't know. See here, we don't know the numbers. How many terms here? It is infinite. Similarly, in these two also. What if I write 1, 3, 5, 1, 3, 5, 7 dash 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 21? Can we say count of numbers here? Means if you keep on writing, you stop till 21. This last one is called nth term. Means last term of a sequence. It's a sequence of odd numbers till 21. So nth term is nothing but the last term in the sequence. This last term, the first term is, see, this is the first term. We represent A1. This is the second term. We represent it by A2. And similarly, it is A3. Similarly, it is A4. What will be the last term if you follow this kind of sequence? It will be AN. It's a subscript here down. Please remember how to write this. Okay. So how many terms are there in this? We don't know. We'll see in the next coming classes how to find the numbers, count of terms in the given sequence. So as of now, we have seen some sequence of numbers. Let's practice this. For example, if I say I'll give the last term by some sequences tn minus 1. Find first, second term. This is a question. So when you want to find the first term for a sequence represented by this form, an is equal to 3n minus 1. To find the first term, you put n is equal to 1. You get the first term, which is 3 minus 1, 2. 2 is the first term. If you want to, there was again second term to find. So 3 n is equal to 2, you put 3 to the 6 minus 1, 5. So this is an example. Okay, this is an example. Then we'll see if these things are added, what happens. See, if I give comma, it is sequence. If I say 1 plus 2 plus 3 plus dash 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 plus n, okay, then the same sequence becomes series. When we put a sign plus or any number, any sign here means plus or minus dash dash dash, it becomes a series. So this series name is called sum of natural number series. What is this called? Sum of natural number means sum of n natural number series. Okay. Similarly, what we can call for the second sequence, we took dash 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 plus n. It is sum of n even natural numbers. Even n natural number series. Okay. Understand the difference between sequence and series. Sequence will have comma in it. Series will have connected numbers by plus or minus. Usually we use plus. Okay. So what do you mean by progression here? In the chapter name we have a progression. What does mean by progression? Progression is nothing but it's a sequence which follows a definite pattern or a rule, which follows a definite pattern. It follows a definite pattern. It's called a sequence. Okay. Coming to the chapter name, other part, arithmetic progression. What do you mean by progression? Arithmetic progression. Let's see. Arithmetic progression is represented by letters AP. It is a progression. It's nothing but a sequence. It is a sequence in which the difference between the two terms is a constant. It's a sequence in which difference between two terms. We have seen the first term is A1, second term is A2, like that. For example, if you want to see 1, comma 2, comma 3 dash dash dash, can you check, is this in AP? Is this in AP? Can you check this sequence is in AP? Then what you have to do, A1 is 1, we take A1 is 1 and A2 is 2, right? Therefore, if you see the definition, difference between any two terms, if you take, it should be a constant, means you should get the same value. That is, you see, A2 minus A1 is equal to 2 minus 1, 1. Similarly, if I assign A3 equal to 3, A3 minus A2. Remember, the difference between two immediate consecutive terms you have to take, not A3 minus A1. Okay. So 3 minus 2, 1. Since this constant, we can say it is in AP. Yes, it is in AP. This understood? We'll take one more example. Let's see. 2, 4, comma 6 dash dash dash. Can we say is this in AP? Similarly, A1 is equal to 2, A2 is equal to 4, A3 is equal to 6. Just find A2 minus A1, 4 minus 2, 2, A3 minus A2, 6 minus 4, 2. Yes. If you get the same values here, you say yes, it is in AP. Right? Coming to the definition, this constant we've obtained, right? 1 and here in this second example 2. What are these called? As the definition says, the difference between two terms, if it is constant in a sequence, then it's called AP, right? So this constant is called common difference. Please understand the term common difference. Constant in AP is called common difference. This is denoted by CD. Okay. So for any given sequence, if you want to know whether it is in AP or not, just find the common difference for 2 to 3 terms. Means like this. Don't just find A2 minus A1 and say it's an AP. No, you may not get. For example, I say 1, 5, 7, 9, 11. I give. Check out A2 minus A1 is 5 minus 1, 4. A3 minus A2 is 7 minus 5, 2. Similarly, A4 minus A3 is 9 minus 7, 2. You may get here and there constants, means looks like similar number, but not every set of operations. Okay. If they ask you to find whether they are in AP or not, you have to do 2 to 3 subtractions, consecutive numbers, terms, sorry, consecutive terms. Okay, clear? So this constant difference is called CD. Okay. Now we'll see. So in this, what we got is A1 is 1. This is called first term, and CD is equal to 2 minus 1, that is 1. Means A2 minus A1. Correct? And CD is represented as D also. CD is represented as D, common difference. You see the general form of AP. General form of AP. What do you mean by general form? For any sequence to be in AP, it should align to this form. Means the first term should be A. Second term we obtain by adding the common difference to the first term. And third term is obtained by adding the common difference to second term, that is A plus D becomes 2D, right? Again you add D here, you get this term. You add D here, first term, you get the second term. Similarly, fourth term becomes A plus 3D. Here plus D you add, you get the next term. Like that, you get the general form. Okay. What will be the last term? It will be AN. Okay, AN. Let us see how do we write AN in this form. Okay. See, the first term A1 is A. Second term is what? A2. We get first term plus D, right? First term plus D. That is, I can say A of 2 minus 1 plus D means A 2 minus 1 is 1. Okay, understand this? Just a general. It is to obtain the formula for the last term. We are deriving something like this. A3. What is this 2 means? This 2. Okay. For second term, if you add D, you get third term. What is second term? A plus D, right? So that's what I gave you. The general form is here. It is terms A1, this is A2, this is A3, this is A4, right? So A2 becomes A of 3 minus 1 plus D. Means A second term you are adding D, you get the third term. Please understand this. When you see in a live example, you will understand this. So if I add like this, see 3, 3. What if I want to get the last term? Then you have to have A of A plus, sorry, So, okay, I think this can be understood in this way also. I'll to do that. What is a first term here, right? Okay, everything can be added in the first term only. I'll a mistake, I guess. So second term is obtained by adding a1 plus d. My mistake. A1 plus d. Then third term is obtained by a1 plus 2d. Means this d and this d you add, you get a third term, that is a plus 2d. See, if the sequence a d is increasing by 1 multiple, so a1 is equal to a plus 2d, a3, a4 is equal to a plus 3d. Means if you observe 4 and 3, how can we write is a plus 4 minus 1 into d, right? This is fourth term. Similarly, an can be written as a plus n minus 1 into d. See, you n and n here, 4 and 4 here. Once you see the example, you will get it. So, the last term of AP is given by this form. Last term of AP. That is an, last term of AP. And this last term is nothing but you have another notation for this. So, last term is represented by a plus n minus 1 into d. A plus n minus 1 into d. A plus n minus 1 into d. This is notated denoted by L also. Denoted by L also. Means what we understood now is AL is equal to A plus n minus 1 into d, or we can also write AN is equal to A plus n minus 1 into d. This is the nth term of the AP. Remember that. Okay. So general form is something like this. A comma a plus d, general form. A plus d, a plus 2d, a plus 3d, dash dash dash, comma a plus n minus 1 into the last term. Okay. So if you are asked to find fifth term, what you can say is a5 is equal to a plus 4d, you should say. If you are asked for to find eighth term, is you just put n is equal to 8 here. Okay. Understood? If you want to find the eighth term, put n is equal to 8 here. A8 is equal to a plus 8 minus 1 is 7, 70. Understood? So A8 is a plus 70. Directly one subtract and do it. Okay. Sometimes the AP can be finite or infinite. Infinite. What do you mean by finite AP and infinite AP means? If terms are finite, then it is finite AP. If terms are infinite, then the AP is infinite. For example, if you see this AP, there is no last term. What do you mean by finite? You will have the last term defined, means where it ends. That is not there means it's a infinite AP. If it is there, the last term, then it's called finite AP. Okay, it depends on the terms in the AP. Let me recap. If terms are finite in AP, then it's called finite AP. If terms are infinite in the AP, then it's called infinite AP. Let's see one example. So 6 comma 9 comma 12 comma 15. Here check whether in AP first part, also find eighth term. Okay, let's see the first part. A1 is 6, A2 is 9, A3 is 12. To check whether it is in AP, you have to find the common difference. 2 to 3 times you have to find. See, A2 minus A1 D is equal to 9 minus 6, 3. Also D can be found by A3 minus A2, that is 12 minus 9 is equal to 3. Therefore, we say D is constant. Therefore, given is in AP. Okay. This completes the first part. They have asked also find the eighth term. Therefore, eighth term is means you have to find eighth term means A8 you have to find, right? We know An is equal to A plus n minus 1 into D. N here is 8. Okay. So 8 An means A8 you have to find. A8 is equal to A plus 70. So A is what? Is nothing but A1. Remember that A and A1 are always first term. So 6 plus 7 of D is what? 3. 6 plus 21, 27. What do you mean by 8th term means? If you keep on writing like this, so 8th term will be your 27, what we found just now. Okay, clear? So, see, what is D here is nothing but that if you want to take D value, that is common difference. Understand this concept, this is very important. D is always A of n plus 1 minus an. This is the form. How do we verify for this is, see, D is, if I take 4 n as 3, it will be fourth term minus third term, right? D is, if see in this example of what we solved here, A2 minus A1 means n is 2 means 2 plus 1 3 means third term is what? 12 minus n is 2 8, 8 second term 9. So D is equal to, if I say n is equal to 2, 2 plus 1 3 minus 2, third term is what? 12, second term is what? 9, that is 3, right? Understand this, very important. D is nothing but difference of any two terms before the term. If you pick any term, say for example I pick a fourth term, D can be found by fourth term minus third term, that is your D. That's what it is said in the formula type, nothing much. Okay, understand this. So we have studied, to summary, what we have studied is A is the first term. A is the first term. We'll just recap and wind up the class. A is the first term. D is a common difference. And general form is, okay, I'll write, give me a second. Common difference. General form is A plus D, A plus 2D. Common difference. General form is A plus D, A plus 2D, dash dash dash. Last term is given by A plus an minus 1 into D, A plus n minus 1 into D. This is also can be written as L as last term. D can be found by n plus 1 minus an. These are the things we just saw in this class, basics to the arithmetic progression. Okay, thank you.